Welcome to section 11.1 and 11.2, and we're going to do these two sections together. The majority of the material is 11.1. 11.2 just does a little bit of an extension, and we will talk about both in class tomorrow. But really what we're trying to look at is mean, median, mode, which you did in middle school, and we're going to expand on that a little bit. What I want to start with is the frame. And again, when we talk about central tendency, this is the big idea. We're talking about things like the average or the most often or the mode, things that occur in the middle of our data set. And so what we want to talk about are statistics to compare and summarize. And we're going to talk in general about 5 things. The first thing is mean. The word that you're used to hearing the most often is average. The second one is median, which just means middle. And then the third one is mode, which means most often. And this is kind of things to keep in mind as we're going through. Let's start first with the mean. We again said the mean, or the word that you know the most, is the average of the n numbers. And it's the sum of all of our numbers, and we divide it by how many there are. And so we give it to you in a general formula. If there are bunch of numbers, and we call it, in general, x1, x2, x3, all the way up to xn. What we do is we add them. So x1, x2, x3, and we add them all the way up until we get to xn. And since there are n numbers that we're working with, we divide it by n. You use the average most often to talk about test average or quiz average, things like that. But this is kind of the idea as we go through. The median is the middle number in our set of data. And now what's biggest and the most important thing about that is it has to be written in order. So we are going to be looking at things like, I'll give you a set of data. Like if I give you 2, 3, 4, 5, and 6, okay, and I give you this set of data. Basically, we're looking for the number in the middle. If there is an odd number of terms, so 1, 2, 3, 4, 5, since there are 5 terms, then there will only be one single number, and in this case, the median would be 4. However, sometimes you're going to have an even number of items, like 2, 3, 4, 5, 6, 7. Let's say do this. And what we normally do, and I think what they taught you in middle school, is you kind of cancel off the first one and the last one, and the first one and the last one, right? So if we do that, the first one and the last one, first one and the last one, we're left with 2 numbers. And if you're left with 2 numbers, then in order to find the median, you take the average of the 2. So 4 plus 5 divided by 2. Well, 9 divided by 2 is 4.5. And so the median number for this set of data would be 4.5. So just kind of keep in mind, it depends on how many the numbers there are. If you can cross off and you're just left with 1, then that's the median. If you're left with 2, you have to find the average. We give you 2 sets of data, and in order to do this lesson, you really should have watched one or both of the videos on calculator usage. If you haven't, stop this video and make sure that you've gone back and watched that, because I'm not going to show you your calculator in this one. But take a look. As you're going through, what you want to do is you want to basically find the mean. And if you're doing this by hand, let's say you don't have a graphing calculator, you're going to add 15 plus 17, 17 plus 17 plus 18 plus 19 plus 21 plus 22 plus 25. And you divide by 1, 2, 3, 4, 5, 6, 7, 8, 9, because there are 9 terms. If you use your calculator, you put all of this in your stats menu, and then when you're done, you hit calculate a 1 variable stats. And what I'm going to do is put these in order. So I want the first one to be the mean, second one to be the median, third one to be the mode. And so if I look at my mean for this set of data and I use my calculator, what I find is that the average or the mean is 19. Again, don't forget mean is found by x with the bar over top. The second one is the median, and the median your calculator will give you, or you can just kind of cancel off term by term if you want. What you end up finding is the median is 18. And the mode is the number that's used the most often. I think it's pretty obvious in this case that 17 is used the most often for Class A. So you do the same thing. Now, if you're just doing mean, median, and mode, sometimes it's really quicker just to do it in your calculator instead of actually going to the stat menu. But if we take a look at Class B, if I'm going to actually start with mode, because I can see 22 is used the most often. If I do median, you could again cross off term by term. This one. Oh, 22 is the median as well. And you could do the mean if you wanted by taking 16 plus 18 plus 19, so on and so forth, right? Plus 25, all divided by 9. You could do that as well if you wanted. But here's what ends up happening. You get a mean of 21. And what we talk about the most often is the mean or our average. And we use it a lot of times to compare our classes to say, okay, if this is quiz averages, obviously Class B scored higher than Class A did in the long run. And so that's one way of looking at it. This example 2, which talks about siblings in Algebra 2 class, what I'm going to do is actually I'm going to make this an in-class activity. And so we're going to use this as our warm-up. And one, I'm interested to know how many siblings you have, but also we can double check at that point in time if you know how to use your calculator. So just be aware this is going to come up. The second part of 11.1 talks about measures of dispersion, and I want to talk about dispersion for a minute. And the biggest part of dispersion is basically how spread out the data is, and that's huge. The question is, how is our range? And we're talking about two different things, range and standard deviation. Range we did in middle school. That should seem familiar. Standard deviation is brand new, so we're going to talk more about it. But I want to first start with range. In order to find the range, we take the highest value and we subtract the lowest value. And if you look back on the other side of your frame, and we want to figure out the range for Class A. Well, in Class A, the highest value was 25. The lowest value was 15. Therefore, the range was 10. In Class B, the highest value was 25, but the lowest value for Class B was 16. So your range is 9. And again, highest minus lowest. Your calculator will not do range, but they will tell you the highest value and they will tell you the lowest value. You will just have to subtract them. When we look at standard deviation, there is this extremely long formula. And back before calculators, we used to do it without a problem. Now, we're going to make our calculators do this to save us a little work. The standard deviation is found by this formula. You take the first value in your data set and you subtract the mean. And don't forget, mean is x bar. If you square that, then you go to the next data set and subtract the mean and square it. And you keep going until you get to the last data set and subtract the mean and square it. If you divide all of that, basically it's asking you the difference of the mean squared. If you do all of that and divide by n and square root, that's the standard deviation. And that's exactly what your calculator does. Again, I'm not interested in doing this by hand, but when you get to your calculator and you're looking for the standard deviation, you're looking for the sigma notation. Okay, so let's do this. You should already have the data for Class A in your calculator. If it's not, put the data back in. And once you actually find the data, we're going to ask you a few things about it. Now, the data, the mean of the original Class A data is 19. And again, you could use that 19 to find it. Now, let me give you a brief look at what it is. If my score were 15, then I would find the first deviation, which means I would take my score minus the mean. I get -4. So what do? I square that, and that gets me 16. And then I do the same thing for my next score, so 17, blah, 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 blah. And what I would do is add all of these values up, and then square root it and divide it by 9 because there were 9 values. Now this is crazy, absolutely crazy. But what we do in our calculators is the same thing, and you should get a standard deviation of 2.94. And if you stick that in your calculator, make sure that you get this standard deviation. If you do the standard deviation of class B, again, we give you the class B data. You want to stick it in your calculator again. Please pause this for a moment and then find the standard deviation. When you do that, you would find the standard deviation for class B is 2.71. Now the question is, which set of data is more spread out? And what we're looking at is class A, because they have a higher standard deviation. And the standard deviation we're going to talk more and more about, but basically a standard deviation gives you a certain percentage of the data away from the mean. And so that's one first idea. The second thing we're going to talk about is an outlier, and an outlier is huge. An outlier, by definition, it has the word out in it, basically means it's away from the data. And so we're going to use that to find the mean, median, and mode. And so what I want you to do is put the data in for these soccer scores. So they play 9 soccer games, and here's the scores of the game. If you stick this in your calculator, or you can do it by hand, but because I have to do standard deviation, I'm going to my calculator. So take a minute, plug it in. Okay, the mean for the 9 soccer games is 3. The median is 3. The mode is 3. The range, the highest is 5, minus the lowest is 1, so my range is 4. Standard deviation I'm doing in my calculator, you should get 1.15. If you say 1.2, I'm okay with that as well. Now, here's the only thing. When they play their next game, what they find is that they won by 9 points. Which, if you look at the data is like from 1 to 5, so it's pretty close together, and then all of a sudden I throw a 9 out at you. 9 is an outlier. Okay, so if I go back to my data set and add one more value of a 9, here's what happens. My new mean is 3.6. Median is still 3. Mode is still 3. But now range, my highest value is a 9. My lowest value is a 1, so my range is 8. And my standard deviation now is 2.19. And here's what you'll notice. The standard deviation measures how spread out the data is. If you look, I add an outlier in and the data gets more spread apart. So unless you add a value that's right there within the previous values that you had, what you're going to find is that your data will get more spread out. Now, which does the outlier affect the most? And what you'll notice first is the range is most affected by the outlier. Now, standard deviation also gets affected. And so these two are affected the most. And I'm going to leave both of them because they kind of tie together. So basically, here's the idea. The dispersion measures are the one that are affected the most. The ones that are affected the least is mean, median, and mode. And so the central tendency is what we called it as we were doing the notes. The central tendencies seem to be affected least, but the range and standard deviation, the dispersion, is affected the most. And so these are the main ideas in section 11.1. What we're going to do in 11.2 is basically say, okay, what happens if I change my values? What does that do to my statistics? So if you look at 11.2, we're going to look at basically what happens when we do two things. The first thing we're going to do is add a constant. Our constant can be either positive or negative, it doesn't matter, but we're going to talk about what happens. And then after that, we're going to talk about what happens when we multiply. Okay, take a look. When we talk about adding a constant to the data set, we're looking at a couple of things. We want to talk about the fact that the mean, median, mode of the new data can be obtained when you just basically, what it's saying is if you just add the same number to the mean, median, and mode, then you'll get the same value. The standard deviation and this should say, I'm sorry, the range are the same. And we're going to show you how that works. Okay, so take a look. We give you some data for a chemistry class midterm. Okay, and these are percentages based on how the students did on their chemistry midterm. Now, what I want you to do is put these data points right here into your calculator. If you do that, you find that the mean is 90, the median is 90, the mode is 93, the range is 98 minus 83, so my range is 15, and my standard deviation, again, we're looking at sigma x. Take a look, you get 4.796, and I'm going 3 places out if I can. Okay, now here's what I want to do. Let's say this chemistry teacher decided that if you did the bonus assignment, we would add 5 points to each score. Okay, so I take my new scores. 84 plus 5 makes 89. 89 plus 5 is 94. The next one, 103, 91, 101, 88, 92, keep going, 98, 96, 98. Okay, and what I want you to do is go into your menu, go into your data that you have in your graphing calculator. And what you can do is just put 84 and then plus 5 if you want, or 89 plus 5. And you could add 5 to each point. Or you could go up to list 1, and if you highlight list 1, all you have to do is say plus 5. And what it will do is add 5 to each data point. To each data point. Okay, once you've added 5, no matter if you're going to use this or if you're just going to actually plug in the new numbers, what we want to do then is we want to look at what is the new scores. Well, the new score is 95 for the mean, 95 for the median, 98 for the mode, 15 for the range, because now it's 103 minus 88, and then 4.796 for the standard deviation. And so here's what we found. Take a look at what changes. If you look at this, the central tendency changes. So the mean, median, and mode are the ones that are going to change. And how do they change? We added 5 to every score, so these went up by 5. The range and standard deviation, so the dispersion stays the same. Now, if you remember this shortcut, you don't have to change every value in your calculator. Feel free, you can. But again, if you know this little rule, you don't need to even use your calculator. You can just add 5 to each mean, median, mode, and then leave the range and standard deviation the same. Now, let's talk about what happens when we actually multiply. And this is where things kind of change a little bit, so we do want to talk about that. And so we're going to talk about when we multiply. And I need to classify this in 2 ways. I need to look at the fact that you have a multiplication of a positive number and multiplication of a negative. So we're going to start with positive first. Mean, median, mode, range, standard deviation. So if you notice, there's all 5 statistics can be found by multiplying our original by the new constant. And so in this case, when you multiply, everything changes. So here we go. Let's go back to some data. Go back to your stat menu, and we're going to put in this data set. When you put in this data set, I want to count how many numbers. 1, 2, 3, 4, 5, 6, 7. In this case, there are 7 numbers in case we need this. The mean for this is 21.7. The median is 25. The mode is also 25. The range, you have 28 is your highest, 8 is your smallest, so 20. Standard deviation is 6.41. Okay, now what we want to do is go back to your stat menu. Okay, again, and I want you to multiply each value by 2. So change each data point to 2. What that means is you have 38, 50, 56, 40, 54, 16, and 50. And we want you to put in these new values. Again, you can do L1 times 2 if you want, or you can just multiply each value by 2. But here's what we find. Your mean is now 43.4. Your median is 50. Your mode is 50. Your range is 40. And your standard deviation is 12.82. And we want to compare these. If you do 21.7 times 2, you get 43.4. If you take 25 times 2, you get 50. If you take 20 times 2, you get 40. And 6.41 times 2 is 12.82. So again, here's what you notice. All stats change. Okay, so when you're multiplying, and again, don't forget, when you're multiplying by a positive, all of your statistics will also get multiplied by that positive number. I'm going to leave this one. This one I would like you to do on your own. You can use your calculator, but this is in order to get the notes points. I want to make sure you're actually using your calculator and doing it on your own. Okay, so the difference is what happens with a negative. This last set of data is giving us there are 10 values to put in. So once we put it in, we get a mean of 15, a median of 14. We have, in this case, 2 modes, because if you notice, 12 happens twice, and so does 15. And so because they happen the same amount of time, they both are the modes. Your range, 25 minus 10, is 15, and your standard deviation is 4.38. Now in this case, we're going to multiply everything by -2. So again, you can take L1 times -2, or you can just multiply each value by -2. But if you do that, here's what happens. The mean is -30. The median is -28. The mode is -24 and -30. The range is +30. And the standard deviation is positive 8.76. And I want to talk about what in the world happens here. These two, range and standard deviations, are measures of dispersion, and they're talking about how spread out our data is. Now, as you look at this, here's the big thing. This is a distance. This says how far away from our mean. And since we're talking about a distance, can distance ever be negative? The answer to that question is absolutely not. And so this will always stay positive no matter what you multiply by. And so that's something to keep in mind. What happens with a negative? And so just in general, again, when you multiply the mean, median, and mode, this gets multiplied by the actual value itself. But the standard deviation and the range only get multiplied by, I'm going to say, the absolute value of whatever that number is. And so this is always the positive version of it, because again, distance can't be negative. And so that's kind of the thing to keep in mind. We'll discuss in class more of how to make sure you know how your calculator works and what's the quickest way to do things. But this is the overall idea for sections 11.1 and 11.2.